Hello people and welcome to my FPGA course. In this course I will show you how to design your very first component. Links under the description that can show you how to install the Xilinx IDE. Just as a reminder, I just want to tell you that I'm using this board, the Elbert V2 from the matter. Design a system or FPGA, what you want at the beginning is just to define what are going to be the inputs of your system and what are going to be the outputs of your system. For this is a problem, we just want to start with one output, so it's a LED 0, and then we will have two inputs, switch 1 and switch 2. So since this one is it's actually an easy case, I will show you how the black box might look inside. But for that, of course, you have to know the hardware that you're working with. So here's the hardware I'm working with. Here's what the inside of the black box looks like. Our switches, I actually have some pull-up resistors, R1 and R2. And when you use a pull-up resistor, if your switch is at logical high, if you close the switch, it means that the output of the switch is at logical 0. And when the switch is open, you have a logical high in the output. So it's a kind of an inverted logic. Since the logic of our switch is inverted, it means that I have to invert the logic before to enter my OR gate if I want my LED to turn on as I press switch 1 or switch 2. So that's why I have those inverted symbols here. So I think now it's time to go to the Xilinx IDE and to go through the code line per line, and I will show you the most important things. So let's switch. So let's start with the VHDL module. First thing we have to do here is to define our black box. So the black box is called an VHDL entity. As with the black box that I just showed you before, the first thing, as with the black box that I just shown you before, the first thing you have to know about your black box is the in and output. As I showed you before with the black box concept, the first thing you have to know about your system are the inputs and the outputs. So I have PB1 as input, line 34. That's my input. I'm using data type standard logic. The data type standard logic has several logical values like logical high, logical low, and so forth. So the line 36, I'm defining my output, and it also has the same data type. And notice that you should not put a semicolon at the end of this line. Just have to close the brackets and put a semicolon to end the entity definition. And mod OR gate. And the next thing you want to define is the architecture of your system. So the architecture is actually defining what my system is doing, and the architecture always starts with begin and it ends with end. So here the name of the architecture is behavior OR gate of module OR gate. So the behavior of the entity is, and describe the beginning of it, and line 40. We're inverting. So what line 44 is saying is that we're inverted whatever the value that we have on PB1, and we're also inverting whatever the value we have on PB2, and we're ORing those two logical values. And what we find as output, we send it to the LED 0. So that's it. Now let's go to our UCL file so that we can define the connections of different pins. So now, first thing we have to define is our LED. I have already done it. LED is defined, it's good. Just need to uncomment it. And here we need to uncomment and this one too. So now I have PB1 and PB2. And notice that we have pull up here. So it's really means that from the hardware we have a pull up resistor which is programmed on it. So it's working on some kind of inverted logic. And you really have to think about it when you're writing your code. So now I have to select my code, actually, yeah, my VHDL module I meant, and just need to we do a change on purpose just in order to show you all the steps. So now I have to synthesize first. Once the synthesizing is finished, I will then implement the design. And on the step of implementing the design, in this step, if your UCL file is not correctly defined, you will run into errors because it will not find the pins that you're supposed to be using. But it looks like everything is running fine, so it should be good to the end. Since I tried to double check everything. Good. So that's actually the last step that we have to do, is to generate a programming file. So we've successfully generated the programming file. Now what we need to do is actually to program our board. So that's actually the fun part of this whole project, isn't it? So right now I'm connected to my board, and I have to start the configuration to make sure that you have it on the right port. On my computer it's COM5. I have to open the bit file first, so it's mod OR gate bit, and then have to program it. It looks like I didn't select the right port, so it's good that we actually have this problem. So if you have such a problem, what you have to do is to call your device manager, In my computer it's in French, but it's more or less the same thing. And yeah, actually it's in COM5, so I don't know why it says that it's not finding it. I have it installed on COM5, it's on port 5. So give it another try. Program, and now it's working. So sometimes you have just weird problems, but when you ask it the second time and it works. So now you can see that it's programming. It finished programming. Now we can test our program.
So if this one is the one, okay. So if I turn this one on, you see that I have the LED which is turned on. Now turn it off, turn this one on. So if now we're on 0. If switch 1 is on logical high, I have my LED on logical high. If I put it on 0, I have it also on 0. If I put switch 2 on 1, I have the output on 1, and if I put both on 1, I also have the output on 1. So we have just realized a OR gate. Our FPGA board is acting like a OR gate.
Xilinx IDE. So I can close this. Go to new project. Give it a name, whatever I want. I would say OR gate BIS, let's say. Next. You have to select the board, select the device type, make sure you have selected VHDL. I can come back here, preferred language VHDL, decide tools VHDL or Verilog. So make sure you select everything right, and here the standard you're using, and then next, and then finish. And once you come here, you want to not a new project. You right click on the hierarchy, new source, VHDL module, give it a name, and what I do here is to call it mod as module, and then I take the same name, OR gate BIS. Next. You don't want to define your ports here. You want to do them inside a program, but instead of behavior, you want to define something like behavior or gate BIS. Next, finish. So now we almost have everything. The last thing we need to define is our UCL file. So we come here, still come to the hierarchy, and we have to define new source, and this time we call it UCF, so implementation constraint file. Give it a name. What I do is to call it UCF and whatever the project is, or gate BIS. Next, finish. And where you can find the UCF file is actually here. You go to the Nemato website, you go to the exact to the page that is linked to your board. Then you go to the downloads. Then here you have the configuration tool, the one that allows you to install the program to the board. And then you also have to take the user constraint file. So you click on it, you select all that. I have already done it, so I don't want to redo it. You could copy paste it into a notepad file, like text file. You copy it and then you put it here. So we will copy it anyway. So I copy it, copy, and I will paste it. Come here, UCF, double click, paste it. No, should. Yeah, now it's good. Now I have to select everything inside here, and no, it's not working. I make sure that I'm selecting everything. Once I have everything, I can then press Alt-C to comment out everything. So now everything is commented, and we will allow only the connections that we need for our project. So that's it. That's the way you can create a new project, create a new module, and then create a UCF file for your project.